Hi, and welcome back. We've got one more video to go with this topic. We are looking right here at strings and file I/O. So we're going to be talking now about actually doing some file I/O, so reading and writing. There's some slides in here that are sort of extra material just for your own interest. So I'm actually, in the interest of time, not going to go through those out loud. I'll just sort of skip over those slides, but they are there for anybody who's interested. But I just thought it would be kind just in case for anybody who's watching this but doesn't want all that extra information. These videos are more just going to focus on the actual information at hand here. Okay, so, oh, there we go. So we're going to be writing code that can read and write text files and also write code that can use data from files to instantiate different objects. So file I/O in Java is pretty simple, actually, thank goodness. However, there are lots of layers to it that have sort of allowed us to get to this point. So Java has multiple built-in classes for reading and writing to a file. Some of them are quite low level that don't really offer a lot of usability for like us as users. But then there are mid and high level classes that are sort of wrapped up on top of it. You can kind of think about it how primitive values are wrapped in wrapper classes. These are sort of wrapper classes that wrap around these lower level classes to offer more methods and make them a lot easier to use. For example, instead of reading something in by bytes or by characters, like individually, we can now read in by words. So that can give you kind of an idea of the difference between like a lower level class and something that might be a little bit higher level in terms of usability. So Java will read and write through these data streams, and it will either be in bytes or in characters, but thankfully we have wrapper classes that will allow us to read in more than just one character at a time now. So typically when it comes to reading or writing, like we're going to open up this data stream. So we build some kind of an object. We use the object's methods to pull the data out. And then when we're done, we close up that object. Usually there's a .close method, which allows us to close that data stream. Typically for programs of our size, closing the data stream seems silly because we open the data stream at the start of the program, we close it, and then the program closes out completely. Like we finish executing, and the last thing we do before we finish executing is closing the data stream. But it is good practice to get into because for the writing portion of it, we open our stream and we can use it to write some data. But when we actually close the stream on the object, part of closing the stream actually takes that whole stream and flushes it into a file. So closing it is part of closing a writing file, allows us to actually do the writing to a file. So getting into the habit of opening and closing appropriately is very helpful here. It's also helpful in future scenarios where perhaps you have multiple different methods that are reading and writing from the same files. So being in a habit of opening and closing our streams whenever we start and end using them is just a really, really good habit to be building right now. Okay, so let's first, start talking about the low level first. There it is. So FileReader, which we will actually use a teeny tiny little bit. So FileReader is super low level. It's a very basic reader, and we don't use it to actually read from files. We just sort of use it to help open up files. So typically we use it with the first constructor there, where it shows a file reader, fr equals new file reader, and we give it the name of the file that we want to open, and then we're able to use that file reader as that data stream. We don't typically use it in the second instance, but it is something you can do, which is new file reader and pass it a file object. But that sort of then bottoms out what we can do with it as a basic reader. So we use it mostly just to open files. And then once we've done that, there's not a ton that we can do to actually get stuff out of the files with just a file reader. So then we use a wrapper class. So BufferedReader is another class, and the BufferedReader class is like a Java class, and inside of it, just like our person objects have names and ages, BufferedReader, it has an attribute, and the attribute is a file reader. So you actually pass a file reader in, and it allows us to have some more user-friendly methods. It's not as fancy as other things we're going to see next, but it is quite helpful. So it has like a read line, and every time that you call read line, it reads the next line of the file. And then we can do all sorts of things with it. Like we can split the line up, and we can parse it in lots of different ways. And when the file is completely empty, our code will just, the read line file returns null. Read line returns null. So let's take a look at this for a second. So to make sure my screen sharing is working properly, looks like it is. So that is always great. Let's just zoom in. Okay, let's just start by making some kind of file here that's going to have pieces of data on the lines. We'll just do like that many. And we're going to call this numbers.txt. So we can just do some practice here. And we're going to make a new, this will be a, public class BufferedReader example. And save .java. Okay. So we're going to read from that numbers file, and effectively what I'm going to do is for each line, I'm just going to add up all the numbers on the line and then print out that total for every single line here. So the first thing that we need to do is, since we're doing file IO, we do need to import java.io.star so that I can gain access to things like BufferedReader and FileReader. So I can say FileReader fr equals new FileReader numbers.txt. Now it's really important to notice here that I can say numbers.txt directly without like this whole path and everything, because my Java file is on the exact same level as my numbers.txt file. So as long as those are living in the same directory, you don't need to put the whole complete path here. You can just say numbers.txt, and the file reader will look for numbers.txt in the same file structure folder as wherever the BufferedReader example.java is. So this will work no problem. And then we can make our BufferedReader. I'm going to make this a little smaller so we can see more at once. BufferedReader br equals new BufferedReader, and it takes in the file reader. Now, as soon as we start using FileReader, our code is not going to compile the way that we want it to. And that is because .java, we have checked exceptions that we're not currently checking. So we have an unreported exception, file not found exception. It must be caught or declared to be thrown. So we have to say we're going to do something with it. So we have to do try. We have to put all of our code inside a try when we're doing our file reading, and then we can say catch file not found exception is what it said I have to catch, file not found exception. And then I can do with it whatever I want. I'm going to do file not found exception dot print stack trace, a method I know that exceptions have. So let's just pretend for a second that I made a random file name here that I'm trying to open that doesn't exist. So now when I run this and I say Java BufferedReader example, I'm going to be able to get that error, file not found exception, no such file or directory. So this is the message that printed, and it prints the whole stack trace for me, not just the message. If I wanted to do just the message, I would just do something like this. File not found exception dot get message. This is just a quick reminder from the last video. So here we can just clear this and try it one more time. And we'll see that all we got was this message that came out of it. So different ways to use those exceptions. Okay, but we do actually have a file that we want to be able to open called numbers. So we'll put that back. And now let's go ahead and actually use it. So typically with BufferedReader, you'd make like a variable line, and you'd have it equal to read line, reads entire line. It will return null, like read line returns null if you're at the end of the file. So while our line is not null, let's go ahead and just print out whatever's on the line. But we can't forget to grab the next line. If you don't do this next line here, the grabbing of the next line, this becomes, of course, hugely problematic because you'll just be stuck in this loop forever. Now, this might seem like a good place to do a do-while loop so that you wouldn't have to have like line defined here two different times like this same line twice. But in a do-while loop, you'd still have to check for the line being null because it could be null the very first time through. So sometimes it's just easier to write it like this. So let's go ahead and try this. Oh, unreported exception. IO exception must be caught or declared. So the file not found exception gets covered by numbers.txt, gets covered for FileReader. So because of the FileReader, I needed file not found exception, but because of the buffered reader, I now need to use a different exception, the IOE exception. Good news that I know is that the file not found exception falls underneath the IO exception umbrella. So if I don't want to have two different catches, I can just do this. Oh, that's going to be a capital E, IO exception, IOE, and this will actually cover both exceptions now, so that I only have one catch. It's just nice to be able to do. And I can see that each line is being read in and printed out, and the null does not print out because once it turns to null, the while loop closes off. Okay, so once I have a line, I don't just want to print it. What I actually said I wanted to do was I wanted to go ahead and, oh my goodness, not do that. That's not what I wanted to do. I wanted to go and say string array tokens equals line.split. Now I don't want to split on empty spaces because my file doesn't have empty spaces, and I might actually have to look at my file to see that, but we did, and we saw it's actually separated by commas. So we're going to do that. We're going to separate it by commas, and now I'm going to have a for each loop that will go through each token in tokens and print out the token. So let's see what happens now. Make sure that we are actually getting each of the tokens that we want to be getting. So we totally are. There's the first three, there's the next 5, and then there's the next 2. And we can see that this is working properly because after each line is read, let's just put new line here so that it's obvious where the separators are. And what we'll be able to actually see in just a minute is we read the first line in from the while loop, and then the for loop ran 3 times, and then we said new line and grabbed the next line. Then we did our split, and we ran the inside for loop 5 times, a new line, ran the inside for loop 2 times, a new line. Then we grabbed null, and null broke us out of the while loop. So we can actually really break down to see what's happening here. Only I don't want to just print the token. What I told myself I actually wanted to do was for each of these tokens, I wanted to find out the sum of the values on each line. So we're going to need a sum variable. And for each one of these tokens, we're going to say, whoops, integer.parseInt token. Now, a reminder that integer.parseInt does throw a number format exception. However, number format exception is not a checked exception, so we don't actually have to do anything with it if we don't want to. Summed up is our sum variable. So notice that every time we start a new line, I reset my sum variable to 0. Within a line, I keep accumulating the sum, and then I can print it out after I finish accumulating the sum, saying that for a given line, all summed up, we get this value. Let's go ahead and give that a quick run. Compile, Java. There we go. So 4, 5, 6 summed up is 15. 1, 2, 3, 4, 5 summed up is 15. And 8 and 7 summed up is 15. I had left this print line in, which is why we got all those extra lines in there, which I really didn't want. But there we go. So now we can actually see it. We can see all of the processing that we did and all the things that we're able to do. And that works no problem. Like that works perfectly well. Okay, so that is how we could use BufferedReader. That's a totally fine way to use BufferedReader. Okay, so here are the functions that I just talked about. I really only used one of them. I used the readline one, but there are other functions that we can use. Oh, and even after all that, I never actually released control of the file. I said, don't forget to close your file. At the very bottom of this, after I do my catch, or after I do all my trying, as long as it all goes well, I can go ahead and right here, catch and close both of them, both my FileReader and my BufferedReader. They can also be, depending on how you set up your catches, like if I would have kept these catches separate in my file not found one, wouldn't need to close anything, but in my IO exception one, I could close my file reader because my file reader would have opened properly, but something went wrong with my buffered reader potentially. So it really depends where you plan to close these, but it also depends where you define them and things like that. But basically, I should probably close my buffered reader first and then file reader. Yeah. And so now I'll have closed both of my streams. I should have done that originally, but I was being tricky. So nothing actually changes, but that's what you should do, right? We said we should always do this after any type of file IO. Once the stream has been closed, it also means that if we try to use the buffered reader stream again, we'll throw an exception, which is a good thing because we are purposefully saying we're done with it. And then if somebody else comes in to try to use our code and they start using buffered reader again, they should get an error. They should know that we tried to close it purposefully. Okay, so I used read line. So it reads in the entire line and then it just returns null if there's no more lines. So that's the example that I just showed, but there's also this option of read, and read will read in one character at a time. It returns the character code as an integer, which means you actually have to cast it to a character if you want to use it. But if it returns -1, that actually means the end of the file. So this reads character by character. So in our example, had we done that, it would have read a 4, and then the comma, and then a 5, and then the comma, and then a 6, right? So it keeps doing that. And then at the end of it, it would have done 8, then a comma, then a 7, and then it would have realized we were at the end of file, and it would have returned -1. So you have to watch for that -1 before you cast it to a char to get the right value out of it. So here's just an example in here, but we did already actually look at an example in code. So we did import our java.io exceptions. We did do our IO exception catch. Buffered reader still really only gives us like strings, right? I said characters here, but what I really mean is like strings. It gives us characters or a complete line, but we have to do all the work ourselves. So I used integer.parseInt to do it, but another option, as you can see here, is also to use scanner. So what that would mean for our current example is rather than doing the split that I did right here, we could instead make like a new scanner variable and pass the line in. And now this line is potentially 4, 5, 6, right? And we can, instead of having our for loop, we can say while scanner.has next int, scanner.nextInt, right? So those are methods that we have access to. That's no problem. And this, provided I remember all my methods correctly, would work. I need to import scanner, java.util.scanner. And we can run it. And my sum didn't work for some reason. Scanner.nextInt. It recognized that those were all numbers, didn't it? We should find out because I should know what I'm doing. I should know what I'm doing. Let's see how many times it prints the line. I don't always know what I'm doing, but I should. So let's go here and try this again. Okay, so it didn't actually run this. So maybe that's not the right method because I genuinely don't remember how we should be using it. .nextInt, line reader, .hasNext, .next, wish I remembered. It treats, when scanner reads a line or string, it treats it as a sequence of tokens, any consecutive non-blank characters. So it's struggling because of the format that I've given our string in. So let's actually open up that file and let's change out these commas for spaces. Let's break up these not so consecutive numbers like that. So now those are broken up. So now in theory, this should be able to see each of the integers and grab them. In theory, I literally never use scanner this way if it's not obvious. Ta-da! Okay, so that did work. So yeah, so scanner does have some limitations when we're reading it line by line like this. There are ways to tell scanner what it's delimited by, like what your file is using as a delimiter, whether it's using spaces or commas or whatever. But this works. This works for right now. We just had to tweak our numbers.txt file a tiny little bit to make it work. So just notice the difference here between the two functions. The .hasNext or hasNextInt or hasNextDouble is just asking, is there another one coming? So true or false, is there another one coming when I look forward throughout the rest of the file? And it doesn't actually get that item. It will just get the token that you're asking about. So hasNext will just ask for any token. hasNextInt, like I used, would check for the next, like, is there another integer? .hasNextDouble would check for another double. And so as long as there is one, then you can go ahead and grab it and put it into whatever variable you want to put it into. So we can see here again, .hasNextInt returns true as long as there is a token that exists of an integer type, but it doesn't read it. You have to still say .nextInt, as we can see in the next one there, and it will read it in as an integer. If you try to run that and it's not an int, like if you don't actually ever do the check, but you just call .nextInt, it will crash, like it will fail. It'll be like, that doesn't exist, it's not here. And Scanner also has the option of .nextLine, which we'll see why it could be helpful in a minute, because Scanner can basically do everything that BufferedReader does, given that it can do next line, and it can do all of the parsing for you if you want it to. So when you get a string from readline, we can split it, right? We can split it on lines, on commas, whatever it might be. It just depends on how you want to use it. So I've uploaded a file called 4.2-data.txt, and it's on UMLearn. So go ahead and find it and open up that text file and see what it looks like. See how the file looks, see what the format of the file is, what's on each line, what you can expect. Now, there is no expectation at this point in your programming careers, in your programming education, that you'd be able to appropriately handle all types of exceptions. So notice that the file I'm giving you has a very deterministic format. It has a word and then two numbers. Each line has that, a command and two numbers, and you can assume that they're correct. I'm not going to ask you to error check. In the real world, you would want to error check. You'd want to make sure that the data you're about to get is what you expect. And when we do this in assignments, there will be some basic error checking that will be expected of you. But here you can assume that every single line has three tokens. You'll have the word, a space, a number, a space, and then another number. If the first word is add, you're going to want to add the two numbers together. If the first word is minus, you're going to subtract them. And if the first word is pow, you're going to do the first number to the power of the second number. And you can use BufferedReader or Scanner or however you want in order to complete this pause and practice. Once you've gone ahead and done that and feel really good about using Scanner appropriately, come on back, or BufferedReader appropriately, come on back and we can look at more stuff. So hopefully you're coming back now after looking at more stuff. We're going to just really quickly look over here at the Oracle documentation for Scanner. So if we look at the Scanner Oracle documentation, we know that we can use it like by console. We just learned that we can use it by input like this, new Scanner input. You can set the delimiter, like I said. So by default, the delimiter is spaces, but if you wanted it to be commas, you can use use delimiter, and then you just put a comma in there, and that would work fine. But I want us to just scroll down here to the constructors. Come on. So what we can see here is that Scanner does give us, we can use Scanner without BufferedReader, basically. So what you can do is you can create a file and then put that file directly into Scanner, just like the way that we put a FileReader into BufferedReader, and then you can just use Scanner directly. So rather than doing it this way, we could make a file out of numbers.txt, and then we could use Scanner SC, new Scanner, passing in the file, and now this has the whole file in it. This could read line by line, right? There is an option for like next line or whatever it's called for Scanner. Next, has next line, has long. Yeah, has a next line. So we can do that. We can say while scanner.has next line. We don't even need this one here now because while scanner has another line, as long as that scanner variable has another line, we can come right in here and we can say scanner equals next line. And then we can either use this inside another scanner variable, right? Like we can have two scanners open, scanner2, or we can call it like a line scanner. Or you can actually just do it directly. So while it has another integer, we can just start grabbing integers. Now, because of how I've set up my code and I wanted it to go line by line, this has to actually stay going line by line because otherwise I don't get the output I wanted here. If I made this whole thing just while it has next integer, it will go and like go to each line. So it will first do 4, 5, 6, 1, 2, like it will just keep going. So we won't ever have like the line obvious separators if all we're ever doing is saying, is there another integer in the file? Like it just keeps going. It doesn't stop by line. So that's why here I'm making two scanners to make that work. So all of these are just tools to solve different problems. So when you're asked to read in a file, you have to actually look at the file and ask yourself what makes sense. So for example, in the previous pause and practice that I just gave you, where I give you like those 3 different commands, add, minus, and pow, going line by line made a lot of sense. It makes sense because I'm asking you to go line by line and each line is its own command. So it makes sense to have that as an option. But if it doesn't matter what's on each line, like perhaps you're just trying to find all of the instances of the word the in a book, you don't need to go line by line. You just need to keep going and finding all of them. It doesn't have to be line by line. It just has to be token by token or the whole thing at once or whatever it might be. So then maybe you don't need to use multiple scanners or a buffered reader and a scanner. So it's really important to understand the strengths of each one so that you can pick the right one for the problem that you're working on. Okay, so that's all of our reader file stuff. So now let's talk about FileWriter. I called this BufferedReader example, but then I ended up doing scanner stuff in here too. That's really okay. I mean, it's annoying, but it's fine. Public class writer example. We'll just call it a writer example, and then no matter which type of writer we end up using to write our practice in, this will still technically be right. Correct. Will technically be correct. Writer example. Okay, so the low-level object when it comes to file writing as opposed to file reading is FileWriter, right? Its pair is FileReader, so it makes sense that we have FileWriter, but just like FileReader, using it directly makes no sense. And the constructors look suspiciously similar to FileReader. So it's just instead of reader, it says writer. So new FileWriter with a string, you give it the name of the file that you want to be writing to. And if you say new FileWriter with a file, again, we'll deal with file objects really later as a thing, but technically this will open up a file. So when you call new FileWriter on one of these, if the file exists, it's going to automatically erase everything there and create new content to put it in. There are ways to append to an existing file. These are not those ways. Let's just try this. So just so that we can say, okay, we've done it once. So things that we need, we're still doing file IO because this is the O part of file IO. So we have to import java.io.star. And then we have to try FileWriter equals new FileWriter write.txt. This file doesn't exist right now. I haven't created it, but that's okay. We're just getting ourselves set up here. ioe.print stack trace, just to have something in here that is appropriate. Okay, so here are some of the options here that we have one level above FileWriter. So FileWriter, just like FileReader, we never used it directly. We wrapped it in BufferedReader. That we have PrintWriter for that, where we can call print line, which work just like system.out.print and system.out.println, except instead of to console, it will go to a file. There's printf if you want to format it nicely. And there is another dot format that's similar. And there's also, of course, the close that we should always be doing. So let's add that in. We'll add our print writer. Print writer equals new. Oh my goodness. Print writer FW. So we pass that in. And then we could say something like pw.println. Hey, I am writing a file. And then when we're all done with it, we can close it up. Let's see what happens, shall we? Writer example. Cool, it compiled. We go ahead and we try to run it. And now if we go to, let's just say open, right there, it created that write.txt file. And hey, I am writing a file. So it made it no problem. And we'll just show, hey, this is new information in the file. If we go ahead and now like recompile and rerun that, just remember that what we're going to see happen is, of course, it totally overwrote what was there prior. Especially when we're doing file writing, it's nice to have at the very end of your program, like one way or another. So I'll do it as a finally. Finally, end of processing. Because I don't have any console output. So it sometimes looks weird. Like you're looking at this and you're like, did anything happen? What's going on? So having an end of processing message, just helps us know that we actually did reach the end. Something weird didn't just happen. It's just always nice to have that sort of extra check to remind us in case we forget. Okay. So now we can talk a little bit about file objects. We've seen for FileReader and FileWriter how we're just straight up passing in the name of the file as a string. But then, of course, we have to use FileReader and FileWriter instead of just using BufferedReader, Scanner, or PrintWriter and passing in a file directly. So there is a file object, but it doesn't do any of this reading and writing business, like none of it. All it does is it gives you all the information you need to know about a given file. Let's go check this out right here in the Oracle documentation. So if I Google file Oracle, it's right here, either of them actually, and we can see all the things that it gives us. So first, when we make it, where's the constructor? I'll find it. There they are. So here's the constructor. Really the one that we probably would use is this one right here, given the path name. So it works just like FileReader and FileWriter did with a path name, only now you just pass it into this file object. And then you'll see that there are things like, can we read from it? Can we write to it? Can we execute the file? Can we create a new file? So if the file doesn't exist, we can create one. We didn't have to do .create new file in our code because we weren't using file, but this will create a new empty file named by whatever path I gave it if the file doesn't exist. We can delete a file. We can delete the file when the program ends. We can make sure that a file exists before we try to do anything with it, right? So there's lots of things here. I won't read all of them, but there's lots of things that we can do in here to check to make sure that the file is helpful and useful and something that we can use. So rather than using write.txt right in here, let's go ahead and look up Oracle PrintWriter and just make sure I'm right before I start making crazy mistakes. And look at the constructors and check that out. This constructor can take in file. So instead of a FileWriter, I can totally get rid of the FileWriter. I could have been doing it inline before, but I can just say new file. Since I don't actually need the FileWriter or the file itself, I just need them to go into the PrintWriter. I'm just going to do it inline. Write.txt, save it. Hey, using file objects now. Let's go ahead and run that. End of processing. Hey, using file objects now. So we no longer have to create that FileWriter because we're not using it. We can just use the file directly, and everything else that we need is accessible within PrintWriter. So this also works with BufferedReader equals new BufferedReader. new file, numbers, right? Or, and just because I'm being lazy, I'm just copy pasting, or we could do it with Scanner also, which is super awesome because Scanner can take in a file. So this means that we can fully get rid of BufferedReader now because we can just use new file. So yeah, so that's just another tool in your toolbox when it comes to reading and writing from file stuff. We have this file object. Now I do have this extra material, and I said I wasn't really going to talk about it, but like JFile Chooser actually gives you like a pop-up dialog box to pick your file from, as opposed to like hard coding a file name in. And then there's some information here about the low-level types of file reading that we have. So we read files like as text, as characters, but like computers read it like in binary and as bytes. And so we actually do have data input and output streams that we have access to help with our file reading and writing when it's necessary. But it's cool like we're not really going to need it, and our computers definitely don't need it, but it's kind of cool just to know that that exists and is a thing that you can do. Anyway, so before, remember, we did this practice with 4.2 data.txt, and we were printing stuff to the console. Go back, do it again, only this time, rather than have your console print out, alter that code so that it's going to go to a file instead, and you're going to nicely print out each of the calculations that you had to do in whatever format you want. If you're looking for a little bit more of a practice and a little bit further of a challenge, at the start of your program, you can actually ask the user through like console input if they want to overwrite or append to an existing file if it exists. And then you can actually perform that appropriate action depending on what the user said. So far, I've actually only shown you how to overwrite a file completely. So you'll actually have to go to the Oracle documentation and go look up the PrintWriter append options to figure out how to actually do an append instead of an overwrite. So that's a little extra practice if you want. Anyway, that's everything I have for file IO and exceptions. So now we've got like a really awesome basis of being able to read stuff from files and process it and do all sorts of neat stuff with it. And as I'm saying that, I literally just changed my mind. I'm going to show one more teeny tiny quick thing. I fully changed my mind. I'm so sorry. I'm going to just show a quick thing here that has like information about me. Instructor in the file, and we're just going to call this file people.txt. And let's imagine for a second that we also have our class person. One of our learning objectives was being able to read from files and throw it in a class. And so I want to actually do that before I just like disappear and don't show this. Public class read to object. Read to object.java. Okay, so when you know that you're going to be reading in a file that's like specifically about a given person, a given piece of information, we want to try and hide our processing as much as possible. So for example, the first thing we'll probably do is want to have some kind of a variable with the name of the text file so that it's easy for us to find and use and change. In fact, this probably should be a final string input file name. There we go. Just in case I also want an output file. Whoops, that's very helpful. Okay. So then what we can do is our main is kind of just like a CEO. It should be passing information around as needed. So we can call read file and pass in the input file name. And then we can go make that method over here. But I'm also going to add my end of processing because I like to have that. Let's make sure that we do our import java.util.star and import java.io.star. And then right here, we can say public static void read file, and we can just take in the name of the file, file name. And now we're ready to actually read from the file. So we can say try. I really do like to use BufferedReader, so I'm going to. I'm not going to use Scanner, especially because I have like mixed data here. I'm not going to use Scanner, but you can. So BufferedReader, new BufferedReader. I guess I'll just use FileReader. I'm like on autopilot a little bit right now, but that's okay. There's nothing wrong with using FileReader to do that if I want to. And I will do exactly what I did previously. So I'll have my string line equals BufferedReader.readLine. And then while my line does not equal null, I'm going to do something with line, and then I'll grab the next line. Okay. Now, we need to take a line and turn it into pieces of information and put it into our person object. So let's just add some information to our person object, like a name, an age, and a, what was my last piece of information? Was instructor, right? So like string job, I guess. And we can say public. That doesn't say public. Public person, string name, int age, string job. This dot name equals name. This dot age equals age. This dot job equals job. Now there will be other information, of course, to fill in here. We know how to make objects at this point, but that's not really the point of this here. So I'm going to take my line and I'm going to break it into my tokens as I expect. And imagine that I'm doing lots of error checking, like making sure all the information is there. Like if I'm expecting 3 pieces of information, I should make sure tokens equal tokens.length equals 3, right? I should probably do that. But for right now, we're just going to pretend that I did that. And I would make like a string name, and it will be my first token at 0. I'll make a string, an int age. I'll parse this into my tokens at 1. And then I'll make a string job, and that will be my tokens at 2. And then I can make my new person P equal my new person where I pass in name, age, and job. Okay, so we can do that, and that would, in theory, work. However, when we're creating objects from files, we typically actually don't want to do it like this. Like imagine if I actually did my error checking, this would be a lot of code. And it's a lot of code inside something called read file. This is no longer read file. This is processing the file and turning it into a person. So what actually makes more sense is if we do something like this. We make a constructor that just takes in the line and turns it into a person. And then inside here, we just take in the line and then do all of that processing inside here. All the error checking, all the setting of values, everything can happen in here. And yes, these can now go directly here. But I would still have to error check, of course. But check that out. We can put all of this inside here to sort of split up how we're doing our, I'm going to leave that comment, split up how we're doing our code. It doesn't change the functionality, but it does change looking at it and understanding what's happening. It's obvious to me that this is reading the file. Now I can see that this is the one that's actually going to, that the constructor processes the file. I swear I can spell. So we really want to think about that separation of concerns and where we can be putting those different pieces. Okay, now that's the last thing I wanted to show about objects and file IO. So go do this practice. And as usual, if there are any questions, never hesitate to ask your instructor. And I will see you all for the next video.